Now it is my great pleasure to introduce our next speaker, Dr. Umesh Gupta, Associate Professor at Bennett University. Dr. Gupta is a distinguished academician and researcher with a wealth of experience in artificial intelligence and machine learning.
Ma'am, you are not audible.
Now I am audible, sir?
Yes, ma'am.
Okay. First, I introduce my friend, Dr. Umesh Gupta. Welcome, sir.
Thank you, ma'am.
So now it's my great pleasure to introduce our next speaker, Dr. Umesh Gupta, Associate Professor at Bennett University. Dr. Gupta is a distinguished academician and researcher with a wealth of experience in artificial intelligence and machine learning. Earlier in this program, Dr. Gupta delivered an exceptional lecture on training challenges GAN, where he not only highlighted the theoretical complexities but also explained practical solutions through live coding demonstrations. The session received outstanding feedback for its depth and practical orientation. Today, Dr. Gupta will enlighten us for the fascinating topic of image generation technique. This session promises to delve into the core methods and innovations in image generation, providing practical insights and applications relevant to both academia and industry. We are honored to have him back to share his knowledge and expertise. I encourage all participants to actively engage with this session as it will undoubtedly be an enriching experience. So, sir, please proceed.
Thank you, ma'am.
Thank you.
So I'm going to share my slide. So my slide is visible to everyone.
Yes, sir. Please proceed.
Yeah. Okay, ma'am. So thank you, Shivani, ma'am, for inviting me in
Thank you,
this
sir.
ATAL workshop. And so last lecture was training challenges for GAN. And today we are just standing at the end of this workshop. So till now, like those who are continuously, participating in this workshop actively, so they know that like we start with the basic history of, generative AI, then neural network, then we start with GAN, then training challenges of GAN, then you can say variational encoder and transformers, and we are just coming to here for image generation. So today our topic is image generation technique. So it's a notice for like whatever images I have used today's presentation. It's not mine. It is for presentation purpose only. So we will not use for any commercial use or financial gain. It's for learning only. So what this image? Can anyone say? Yes, the session should be interactive. I know it's 1:30. So I think you already have done your lunch. So yeah, can anyone say something about this image? Am I audible? Shivani ma'am?
Yes, you are audible, sir.
Yeah. So can someone say something, anything like what your mind will say about this image?
Sir, a lot of things I can see in this image.
Okay.
Like color, brush, quotations.
Okay. So any other one word for this image? What kind of image? Colorful. Okay.
Yeah,
Mitakshi
one
ma'am.
Mitrakshi Patil says the colorful,
Yeah.
like holy.
Okay. So like this is a image generated by AI. and it is a artistic view of a image. So yeah, painter, we can say. So we start. Pardon? I think someone might have opened. Nitin sir, you can off the mic.
Muted, sir, muted.
Okay,
Please
so
continue.
these are the outlines like regarding our today's topic about image generation, then image generation techniques, then some experiment on different techniques, then with concluding remarks and some repository and code which will help to you for further exploring this topic and some references. So first understand what is image generation, because we are talking about image generation. So image generation is a process where AI will help you to create new or synthesize images, either from scratch or based on your input. So your input will be in terms of either speech, either voice, either text, either different images or other visual prompts. So on the basis of your text, your sketches, your imagination, or you can say that different images, AI will create a new image or synthesize the image. And these images can be completely new, maybe, or you can say the mimic real world visuals. So it is, it will be generated on some specific rules. The rules will be different. Like sometime we can use conditional image generation. We have, we want one image like a person should be, in a red dress, will be wearing a toppy, and it should be look like Santa Claus and distributing books. So that time, whatever text you have passed, that time you have already mentioned the condition or constraint. Similarly, some style should be there or input will be there, like text descriptor will be there, or you can design some sketches or other kind of image data. So like if we are going for brain signal, so with the help of brain signal, we can draw some behavior of a person in terms of image. So EEG signal to the image journey. And this process relies on generative models, which are trained on large data set of images to understand patterns, texture, colors, and structure. So when we talk about generative models, so what is the meaning of generative models? We already read, in the last 4 days, 5 days of this FDP. The generative models are used for, generating for large image data set. That is GAN. That is transformers. That is, you can say, encoder, decoder, that is variational encoders, we can say. And the new terms today we will know that is diffusion model. So can anyone say something about this image? Can anyone have seen this image previously? Yes. We have a large number of participants.
It's look like any movie scene.
Okay. Okay. And anyone? Apart from coordinators, because we have participants also. You can simply say, at least you can contribute your, thinking in this FDP also. Yeah, so an old era image, okay. Art, okay. So this is, this image won the first place in Colorado State Fair as a AI art. In August, Allen's piece like Theater of Opera is partial, and he created with AI image generator, like the famous software, that Midjourney, and won first place in the emerging artist divisions like digital art. So that's why I have seen, just put this image in our slide. Now, coming back to the image generation, we understand what is image generation. Now, why we are doing image generation? We have to understand, before exploring this topic, we have to understand why we are doing this image generation. So I have written something over there. Number one, you can say it enable artists and designers to create unique artwork, like the previous picture you have seen, the operas, spatial. Or you can say explore new visual style. So that time AI generated paintings and sculptures. So that will be, that is a need. That's why we are going for image generation. Or as well as it will save times and resources by automating image creation. Like for example, suppose we have a number of e-commerce website, or the companies or FMCG companies, they are spending a lot of money for creating advertisement. So with the help of image generation, we can generate product visuals. So like that, you can see. So the first image is AI generated painting and sculpture. I have generated this image from one of the software. And the second is product visuals for e-commerce platform. So these both images are generated through generative AI models. Third, we can say the tailors visual to individual preferences or a specific need, like personalized avatar for gaming or your dress code. Before that, we know the Manish Malhotra in India could design, the Bollywood stars dresses. Now the time has arrived. In this time, the generative AI models can design a lot many dresses, and it will be, the upcoming trend. Is as well as it will enhance the creativity in media and entertainment. Like we know the Astak, at that in this channel, news channel. So we have a anchor like generated from the generated AI. So like that, you can generate realistic movie background also. So which will help, which will create the motivation why we are going for image generation like that. So I have created one personalized avatar for gaming. So it was generated by Leonardo AI website. The second one is generating realistic movie background. So they can use in the picture or and film anywhere. So like that, and as well as it will support scientific and industrial innovation by generating visuals, like for example, simulating medical images for research and diagnostic. As we all are, maximum coming from computer science branch. So we know dynamic programming or greedy algorithm. So in dynamic programming, we have read about assembly line problem. So in assembly line problem, we are solving that problem through dynamic programming. But in this time, you can solve assembly line problem through image generation. You can generate various images and you can solve those problems. So similarly in healthcare sector, in various industrial sector, you can use, the AI generated images. So I have created like one, you can say simulating medical images like that. So you can understand where the lungs is there, where the instantaneous is there, like that something. Now, next topic is, you can say, the kind of image generation. Or kind of image generation means like what kind of images we will get. We have ample amount of images, but before that I have just summarized it, like what kind of images we will get. So first is, we can say, random image generation. So random image generation is like you have some random noise without passing any external input or any supervised with any image. The generator will start random latent vectors. So random latent vector means the low dimensional images. And later on, when you are doing this iteration again and again, that time the images will be more high dimensional and it will produce those images. So when we are doing this random image generation, we already read about GAN. So we have already discussed in last Wednesday. So the GAN was the perfect model to, for random image generation. I have just generated these two images, one from Gemini AI. So here you can go for with the creating abstract art. So this is the best example where we can use random image generation. Number two is text to image generation. It is very popular. We know that. Like we just do some prompting in terms of some words, some line. some scenario, and it will convert to the corresponding images. So like that, I have just created, I just passed Indian Prime Minister Narendra Modi along with in the jungle with a, one lion will be in their lap. Now you can see the picture is generated. So here you can use DALL-E or Mid Journey, or the the technology or techniques behind that is diffusion models. So where it map text embedding to visual output. So like that, I have created another one. You can see like Gandhiji is handshaking to the Donald Trump, but it's not real. We know that. But with the help of generated AI, we can convert this text to image generation here. Similarly, we can see Einstein is, Einstein is sitting and Donald Trump is in the one image. Different data people will be in the one image. Like elephant is in the library, or we can say Zelensky and Putin are handshake. So I have just created random text I just given, and I find it this one. Now the third one is image to image translation. That means I have one image and I just want to transform that image into different structural element, where you can say the it will be either style will be transferred, or sketch to realistic, or day to night conversion, or animated version, like that. So I have just put in my image in one of the image to image translator app, and I got these two. One is sketched image and one is the animated image. So you can also do the similar kind of images through this image to image translation. The next is neural style transfer. So neural style transfer is very popular nowadays, because what they are doing, they are combining the style of one image, like for example painting, with the content of other. So here you can see, like in the right hand side top corner, you can see there is the original image is there, where one house is there, lamp is there. It's the original image, and it transforms into a photograph to mimic like Van Gogh painting style. So Van Gogh is a very popular painter. We know that their painting is very costly, and it can easily convert by using this neural style transfer. And how you will do? By simply implementing convolutional neural network, that is CNN. So we can do the similar kind of thing with the help of the CNN. Or if you get the low resolution image, for example, that time we can use SRGAN, that is super resolution. So over there, you can enhance the resolution and quality of the low resolution images to the high resolution, or you can say the latent space to the high resolution, where we can restore old and low quality photograph. So here you can see the the top bottom side images. We have the building image is low resolution, and the right hand side is the high resolution images. So are you with me? Yes? Any participant?
Yes.
Yeah. So the next one is, we can say, image to image translation. So before that, we have what we have discussed till now. First, we can say is a random image generation, then text to image generation, then we go with the image to image translation, then we are going neural style transfer, and the fifth one is super resolution. Now the sixth one is image to image translation. That means under this process, you're transforming an input image to an output image while preserving some semantic properties. For example, in the first image, you can see the city is same, but before that it was in grayscale, and after that it was in colored. You can say you can do image colorization with the help of this image to image translation, or as well as domain adaptation. You can also do, for example, here we have the half, you can say in the before side, we have this half building. We don't have the full, the full image of this building. But when you adapt the domain adaptation, it will create the rest half part. or you can see the bird's image. Before that, it was the original image, and you can do the image coloration over here. And the seventh one, where we can categorize the image generation, is 3D aware image generation. So these are the, you can say, images where you can simulate three-dimensional structure and their perspective or perception over there. So for these kind of 3D aware image generator, we are using implicit neural representation, that is INRs. And the popular method under this is neural radiance field. So like that, you can see in the top right corner, we have a novel multi-view synthesis. So we have a bulldozer is over there, the toy bulldozer is there, and we have different, you can say, perspective of one image. And later on, we applied to this 3D optimization, and we generate meshes. So here you can see this 3D model over there in the, on a paper. But before that, it was look like a simple photo for a toy bulldozer. And with the help of this 3D aware image generation, you can do with this 3D model. And the last one we can say image compression optimization. So image compression is also a part of image generation. Why I'm saying? Because suppose you are generating an image but takes too much space. And as we know that the space is very costly for us. So that time the both images are look like same, but the first image is getting 5.7 MB memory only. Here it is taking 470 KB. And why we are discussing this image compression and optimization? Because they are also using the same models like what we read in the previous classes, like variational autoencoder or convolutional autoencoder. Or sometimes some of the researchers have used GAN also. So you can do image compression and optimization with the help of CAE and variational autoencoders. So now this is a main topic, that is image generation model or technique. Now we understand what is image generation. Then we understand why we are doing image generation. Then we understand what kind of images we have that we're going to generate. So either image to image, text to image, super resolution image, or like image compression. Now, how we will achieve those images? So that definitely this flowchart will not be available anywhere. I have created for this FDP only. So from different research papers and PPTs. So now you understand this image generation models or technique, we can say. I have just included the popular one. I will not say that these are the only technique. So the first one is GAN. Second one is variational autoencoders. Third one is diffuser model, that is DM. Fourth one we can say neural style transfer. We have discussed over there. Then next one is auto regressor model. Then next is 3D model INR. We have discussed. And here we have CIG or text to image models. So when we talk about GAN, generalized adversarial network, little bit we have already know that there is one is diffuser, another is one is generator, another is diffuser. Sorry, generator and discriminator. So one generator will generate the image and discriminator will try to identify whether this image is fake or real. Okay, so by doing this process, we have number of models where these models will be used for image generation, like DC GAN. So last time on Wednesday, whatever collab program we have done, that was for DC GAN. And then you can do style GAN, cycle GAN, and pix to pix. So I will share this collab file also with all of you, and we can see if we will get time, so we can understand the code also. Otherwise, we will see like what is the difference between this style GAN or cycle GAN or pix to pix. Then in DM, like diffusion, you can say models. So one by one, I have explained in the next slides. I can show you. So first one, GAN, we know that like both networks should be trained in a position and both want to be, win either generator or discriminator, and leading to increasing the elasticity image generation. And number of variants we have discussed in the last slide. But what is DC GAN, what is style GAN, cycle GAN, and pix to pix? I have written one line for these two variants. Like when we talk about the DC GAN, so DC GAN use CNN, or you can say the convolution layer, for high quality output. That means here we are embedding convolution neural network, and it will give, like, the generator will generate the images, fake images, obviously. So it will be high quality, and later on whatever feedback will be given by the discriminator, that time the quality will improve. When we talk about the style GAN, that time it offer control over style. So last time I have shown you, suppose we have a matte finish, we have one image, and you want that matte finish into that image. So that time it will copy that style, or you can say attribute. So that time style GAN is used. Similarly, you can go with the cycle GAN. Cycle GAN is, you can say, perform unpaired image to image translation. For example, we have one image of horse, one image of zebra, and we want the zebra lines should be on the horse. So that time you can use that type of, pairing with combined with the cyclic GAN. Cycle GAN. And the last one is pix to pix. So when we talk about the pix to pix, it is for paired image to image translation. That means, for example, you create, a architecture of a building from the outer side, and you have a real image for a building. Then you combine it, and you will get one artificial image where your architecture and the real image of building will be combined. So that time you will get. So I will show you that images also. So application, we know that is a face generation app, or photorealistic art, or image translation. So that time we can use this GAN. Next is variational autoencoder. So variational autoencoder we have already read. So I am just explaining a little bit. Like, we have two things over there. One is encoder, another is decoder. So encode input image into the latent space. Latent space means like low dimensional space, you can say, and decode them back. Okay. So that time you can say it will learning to reconstruct the images. So that time we are using variational autoencoder. So latent space, you can say, we discussed like samples from the probabilistic distribution and enables generation of a new similar image. So generally when we have very low data and data scarcity, or you can say in the healthcare sector, sometimes we have very, the data set is very limited. So we can apply this kind of variational autoencoder. We can go for the data augmentation. And sometimes if you want to detect the anomaly in an image or in a data set, that time you can also apply variational autoencoder. Similarly, image editing, we also help a lot. Third one is diffusion model, which we haven't read till in this FDP, because we have read after variational encoder transformer. But transformer, can work for images, but very in a complex nature. So I haven't written here. But we haven't read diffusion model. Now understand diffusion model. That means a model learned to revise noise to image transformation process. So it is very interesting. You just understand. You start with some random noise like GAN, if you remember, but iteratively denoise it to form an image. The problem with the GAN is, whatever noise we are applying, later on, the discriminator will try to identify whether it is fake or not, and will give the feedback. So, but here you will start with noise to image. First, you can say the forward pass, and then second phase, backward pass, you will do the denoise it from the image. So in this diffusion model, we are using, various model, but the popular one are DALE E2 or stable diffusion. So I will discuss stable diffusion code with collab file also. So it will, high quality text to image synthesis. And DALE is a popular, website over there. You can use it. Combine text and diffusion for creative outputs. So generally for prompting, we are using this diffuser model, or in painting or super resolution images. So are you with me? Yes or no? Anyone?
Yes, sir.
So can I ask one question? Because we have
Yes,
done the
sir.
lunch. We have done the
Participants
lunch.
also say yes.
Yeah.
Mhm.
So can anyone say which model we have used for super resolution?
Dilemma.
Dilemma is not a model. Yes, anyone?
Stable diffusion
No.
by the Mitrakshi Patel ma'am.
That's okay.
Mhm.
But at least I just, try to scratch in your mind. कुछ करना है नहीं करना है. Yes, anyone? I have discussed when we are going for super resolution. Yes. So SR GAN we will use. That's correct. Or with the help of SR GAN, we can do the style transfer also. Now, the fourth one, you can say what we are discussing. We are discussing the models. Okay. How we will get those images. So the fourth one is neural style transfer. Neural style transfer, I have shown, already that, like where you can use CNN and you can combine them to produce a new style image. Generally, it is used for artistic painting or abstract art. So here we are transferring one image to another image and preserving the content. So for photographic editing, generally it is used. Okay. And one model is also used, NST. I can show you in the collab file also. The next one is autoregressive model. Autoregressive model is like they are generating images pixel by pixel. Before that, we have discussed pix to pix, if you remember. So pix to pix model is a part of GAN. I have discussed this thing where one architecture of a building is there, then you have a real image of a building, then you combine it and you will get the generative image. But here we are talking about pixel by pixel or patch by patch. So that time we are using two popular model, that is pixel CNN and pixel RNN. So when we talk about pixel CNN, that means it model the distribution of pixels conditionally. So either we can use, generally we are using Gaussian distribution here, but sometime it depends on gamma distribution, Bernoulli distribution, what kind of application you are doing, you can use. And RNN similarly like uses recurrent connections for sequential generation. Suppose one person is, just see in the straight direction, then you want that should be moved. So it will be moved. That means left hand side, the next sequence will be there. Then again left direction, then again left. So it will be like from 0 to 90 degree. It will move. We will get 5 to 6 images in a sequence. So applications like data synthesis and artistic generation, we are using this autoregressive model. So these are the popular 5. Next, I have just combined in others because I will not explain the whole, the chart. We can say INR. So INR is like it represents images in a continuous fashion, which will be parameterized by neural network and generally used for 3D image synthesis. We have discussed. Okay. Or where the use of 3D model, you can say in virtual reality, in metaverse, in digital twin, in virtual reality, all these fields will use this kind of model, that is implicit neural representation, and where you can do this kind of activity with the help of neural radiance field. Okay, so it is very latest one. You can also use these 3D model image generation. Next is conditional image generation. So there are some variation in GAN, but we cannot say they are the part of GAN. So like that, we generate images based on some specific input conditions. Like that time, we have some constraint or labels. On the basis of this, you have to generate the image. So that time we can use control net. Control net is one of the popular model for that. And the second is conditional GAN. So conditional GAN is not a part of GAN. It is like you just guide the generation with different input labels. And in control net, you can say you are providing structural control for output, like from sketches to images. Like I say, I have tried, but I haven't put it here. We just visited to India Gate. There are number of, sketch artists over there. They are just, make one sketch, like of you or your friend. But when you see that sketch, it will not be, it will be resembled to your face, but it will not be look like you. But you can do one thing, like you can generate a good photograph from that sketches. So upload it on this control net, model, and do the iterations, and later on it will give you a wonderful image like that. So we have a customizable design, fashion prototyping, like that we can do with the help of this conditional image generation. Here, one of the example is like for mechanical persons, they are using CAD CAM for, designing those nuts and bolts and bottle design and car design, number of things we are doing. But here you can do the similar kind of thing. Like in BTech first year, number of students are going with this mechanical art lab. Okay. And that time, whatever sketching they are doing, if they are just passing those sketching in this conditional gain or control net, that time we can get the, the model for that particular building or entity. And the last one is text to image model. So text to image model we have discussed, but here the difference is we are using one specific model, that is contrastive language image pre-training model, that is CLIP. So CLIP is very famous, like it understands the text prompt and guide the generator. It will not work alone. Definitely you have to combine with GAN or either diffuser model, but who understand the text prompts, that is CLIP. Okay. And guide the generator either in GAN or you can say the diffuser model. So the application is OpenAI or ChatGPT where you are using, or Midjourney. So if we are experimenting on the Google Colab file, so first I will start with the diffusion model. So before that you have covered GAN, VAE and transformer. Now I'm just giving a glimpse of diffuser model. Here you can see there is an image X0 and we are doing the forward diffusion process here. That means we are creating, you can say, the nice noise over there. And we will get the complete pure noise image. And the pure noise image is passed to the unit architecture. Then again, it will generate some images again and again repeated. Then we will get the original image. So here you can see also, like whatever noise, we have the original image and we will get it. We will apply the diffusion process, again add the noise, and we will get what we get. We get the pure noise image, and that pure noise image we will pass in the backward direction to the unit architecture, and there's some another algorithm, that is DPM algorithm. Then we will get the original image, or you can say the new image. That should not be, that will be resembled to the original image, but it will be a generative AI image. So before that, shall we go for collab file first or complete the PPT? Yes, anyone?
I think first you complete the PPT, sir, then you have to move to the collab file.
Okay. Now there are number of, you can say, journal AI platform where we, some of them you already know that is ChatGPT or IBM Watson, or you can say Google Vertex AI, Microsoft Azure AI, or Amazon SageMaker. Some of them are free, some of them are, the paid version over that, but the uses are different. Like for Google Vertex, you can use a cloud-based platform for building, training, and deploying machine learning model. So like when you are spending a lot money for, money for AWS cloud, here you can see it will be free of cost, so you can use it. And similarly, a set of AI tool for enterprise scale solution for data processing and machine learning, you can use Microsoft Azure AI. Then for image recognition and generation, then again you have like Midjourney, DALL-E, Runway ML, DeepArt, or Clarify AI, and Art Builder. So these are very popular, you can say popular app or popular websites where you can use, like they are using those models what we have discussed, either GAN, either CGAN, either neural style sheet or either variational auto encoder. But in this time, you can use the front end. You can simply do the task, whatever task you want to do. Then if you are going for video and audio editing, that time we have again from generative AI, we have a like synthesizer, Lumen 5 that will tune text-based content to the engaging video stories, or like DeepGram where AI-powered speech to text technology is there. Like recently, two of my students just make one project. The project is they want to give the voice command to their laptop and their folder will open. So like that, they simply say, okay, go to like the Cortana is there. So they just give the Cortana, okay, go to Cortana to the D drive, then open this folder, then open this folder, then open this image and then zoom it, then it works. So like that, similar kind of things you can also do with your system without using hand. So that time with the help of the voice command, you can do. So like that, Adobe Sensei, AI powered tool embedded in Adobe Creative Cloud, enhancing image and video editing and design. So you can do all the video and audio editing with these tools. Some of them are free. If you are going for content creation, that time we have a Canva. Canva, we know that. Apart from Canva, we have WordTune and Lumen 5. So Lumen 5 is very popular one because it turns written content into videos. Okay. So like if you have a hobby to write some poetry, so that time it will work for you. And Write Sonic is like that you generate some content like for marketing or for advertising. For example, we are doing this FDP. We are just creating one, before start this FDP, Shivani ma'am just posted my, advertisement over there. So we can do the similar kind of things with the help of these Write Sonic also. Now we have AI for social media management. Like you can use Buffer AI tool. It is for AI driven scheduling and analytics tool for social media platform. Like every time pop-up will come or notification will come, you will be disturbed. So it can summarize over that. For example, on WhatsApp, you can give the permission, or for some different kind of social media. That time it will manage the thing and distinguish spam, not spam, or advertisements and sponsored categories, differently. Now the hot suite is there. It is also a platform that AI powered content scheduling and reporting tool. Similarly, Cortex is there to optimize social media strategy based on data insight. Now these are for PowerPoint presentation or PowerPoint generation. So you can build your PPT with the help of these number of tools like beautiful.ai, Tom, or you can say Gamma. So you can use these tools for generating high quality presentation and advanced design features, where you can write, like they will give you the design suggestion as well as automated formatting is there. Sometime the ease of use is also there. So, and it will take the user input and create it according to you. Now the concluding remark is there. The right hand side picture you can see, I have generated this picture through a text to image, where the top of the images you can see Ajay Kumar Engineering College is written over there, and in this PPT you can see faculty development program for the ATAL platform, and I have just given the prompt like 30 to 35 because my age is 38, so that's why I have just given the the prompt. So it will create an image like whatever prompt we have given. So image generation is like a diverse.
Kindly mute yourself, Mansi. Mansi, kindly mute yourself. Hello.
So it is a diverse and transformative field where we can say techniques tailored to specific application and creative seeds. So we can go with the abstract art like from painters, artistic art to the realistic image. And the power of generative AI is unlocking new possibilities across industries like entertainment, healthcare, so you can say the colleges, for e-commerce site like that. And this is again image I have generated. It's a last image which I have generated from the AI for this FDP. Now I have given these GitHub repositories for image generation. So those who are interested, where the code is available, you can directly download the code with the data set and you can run this code. Again, there are some diffusion model because it will work for image generation. So that time you can, these are collab files, so you can directly start coding and understand how they have done different you can say style of the image. For example, in painting is there, or you can say sometimes TPU they have used, sometimes GPU have used, sometimes video generation is there, sometimes animation is there, like that. And these are the data set where you can do some research. There, some of them are latest one, so you can use Hugging Face, we know that, and like that time series classification data set is also there. These are the references where I have created some images. So before that, I have to go for, yes, my screen is visible, ma'am.
हाँ सर बिल्कुल ही और विजिबल सर.
No,
Screen
this
is also visible.
collab file is visible.
No. Collab
Wait.
file is not visible. Your references are visible.
Okay, so wait a minute, ma'am. Ma'am, now it is visible.
Yes, visible sir.
So first I am just showing the GAN variant, like cycle GAN. Cycle GAN, I have discussed this thing, like this is the input image and this is a predicted image. Okay, so like that we can say this is the input image and predicted image. So here, like, you can perform cycle GAN model and generate whatever kind of style we are transferring from input image to the generative image. So like first you have to go for the input pipeline, then import TensorFlow as TIFF. I will share these all. Even it is also available on tensorflow.org. You can go for that. Then we import here like various model. For example, like TensorFlow dataset as TFDS, we have taken from there, and OS time, matplotlib, like that. Then we create, because we know that pix to pix model over there. Then we first import data sets. So here we have host to Jabra. So we apply cycle GAN here. And then we define buffer size, batch size, because we have already discussed this GAN in the previous lecture. So I'm not going to explain again. And then width and height. Then we do the standardization or normalization, because we have discussed this thing. Then we add the noise, how much noise you are taking as a seed. That is a random jitter. And you do the pre-processing for the test train image. Then what we get this horse with and the second image is the horse with jitter, the random jitter. That means we are passing what random noise in that image. Then later on, you apply then Jabra with the random jitter. Again, you use the pix to pix model here, because cycle GAN will use batch normalization, as we have discussed in the last lecture, as well as the instance normalization. And it use like ResNet. We know that there are number of pre-trained model in the deep learning. So we have a ResNet. So it will use for generator, and the generator, transform image X to Y. Then Y, what they will do, Y will learn and it will transform Y to X again. So the discriminator try to discriminate between X to Y images. What is the difference between the image X and the generated image X? That means the fake image. That time the output channel we are considering here 3. So when we are discussing like zebra to horse, so now you can see first we have the horse here, then we apply, you can say, the random jitter to both of the images like horse and zebra, and what we get here, you can see the zebra to horse will be look like that and horse to zebra will be look like that. But it is the first iteration. There later on you can do many iteration and you will get like the fake image. It will be like it is a real zebra or is a real horse, but it will not be like that in the initial iterations. Then later on you have to update the loss function, and that time the loss function will be updated for generator as well as for the discriminator, and it will you can say give different checkpoints. You can save it at the training time, and last when you apply the testing on different epochs, you will get the image look like that. For example, this is the input image and this is the predicted image. Similarly, you can see this is the input image and the predicted image like that. So it is used for cycle GAN. When we apply pix to pix image translation, so that time I have discussed this thing. This is the input image and this is the ground truth. Now when we apply this input image with the ground truth, this is the predicted image. So recently, like I have published 2 conference paper related to this pix to pix model, and one, that time we have used pix to pix model and improvise it with different kind of, you can say the data set. Then here you can say this is the input and the ground truth is there, predicted image look like that. So how will you do? Again, there is a complete code, load the data set, do the, path will be setted. Then later on, you can say whatever input image you have, what are the, real image you have, then it will be look like that. Similarly, you can show, then resize it. That means you have to go for downsampling up to the normal model and then you go for the upsampling here. In one go you cannot understand, but I suggest if you will get some interest, so definitely you can learn these things in a very quick manner if you know the deep learning prerequisite already. And the third one is neural style transfer. Then what we discussed, like it will transfer the style. For example, this is, let's take an image of the dog and we have a, the different style of this image. We want to take this style into this dog image. So that time it will be look like that. But now we are going to set up the configuration module and all these things.
Hello.
Okay.
Hello, Umesh sir.
Yeah, am I audible, ma'am?
Hello.
Yes, yes.
हाँ sir, you are audible, but your voice is breaking.
Network is stable from my side. Okay. Am I audible now?
Yeah, now it's
Screen
stable,
is
sir.
visible.
Yeah.
Screen
You're
is
audible
visible.
now. हाँ, screen is visible, sir. Screen is visible.
So now the content
Please
image is
continue.
there. That is the style image. Then when we apply fast style transfer using TF Hub, the model is already trained. You can directly use this trained model. And if you want to learn the exactly algorithm over there, what kind of algorithm they have applied, so we will share the paper also. Then you can see this is the styled image they have used on the dog image. So they have used here VGG19. It's again a pre-trained deep learning model and different layers. Then they build the model for the, like we know that first we have to create the generator, then we create the discriminator, and like that we have to create the noise. The loss function we have to design what kind of style we are taking and extend the style. Now again you can see it will take the style of the different image and like that. If we are going for diffuser, so diffuser we have discussed, like it will create first, add the noise to the real image, and it will do, like you can say, up to the pure noise. So, and it is a reverse process. When we get the pure noise image, and it will, in the backward process, we will get the new generative image. So this is a concept for the diffuser model. So like that, we are going for the downsampling, from downsample 128 to 128 to 64 into 64, like that, and up to the middle block. Then we are going for the upsampling here. Okay, so we are using generally UNet architecture here for this paper. And similarly, we are applying denoising diffusion probabilistic model, DDPM algorithm. So then we embedded these pre-trained model from the TensorFlow, and we apply some images. For example, we have just created one image, that is, you can say, the generative AI image here. So like that, we can apply for different images as well as different unit model also. So here we have a model like ResNet 2D model, or you can see UNet 2D model. So we applied here, and then layer by layer we calculated and do the similar kind of thing, like to generate these images. Here you can see these were the diffuser, but later on what happened? Now the stable diffuser is popular. So stable diffuser I have already mentioned in the slide. So stable diffuser is like, it's a powerful version for the diffuser side, where it is, you can say, it's an open source latent diffuser model designed to generate high quality novel images. So here I have already run this code. I think it is on my collab. Yes. So first we just load the dependencies, install the dependency here. Then we import different files. Now before dividing like how latent diffusion model work, first start generate some images by using Keras Hub API. We have used those one, and then we display those images like that. So we have downloaded from the Kaggle. You can see there are different API over here, like, and as well as we apply like stable diffusion, like 3 text to image we have taken here. Now I have just given one prompt like tiger in school uniform, old color palette, muted color, detailed 8K image. Now you can see the image is generated like that. So I can say, for example, similarly, I have created this image also, like Indian Prime Minister. I have shown this image and hold in low-end like that. So anyone can suggest any line I can do from this time also, just from audience. Anyone, any prompt? Because we have trained from this model from more than, I think, 1 billion images. And 60,000, I think it will full fine tuned. Yes, any prompt? Anyone want to generate the image? कोई कुछ बोलना चाहेगा? शिवानी मैम, नितिन सर,
Yes, sir.
any prompt?
Yes, participants.
Patil ma'am is active. I think she can say.
Patil ma'am. There is no answer received from the checkbox right now.
So any prompt, what can we say? Yeah.
Yeah. Create.
E-man with his
E-man.
loan. Okay. And should be cold color palette, or we have to change warm kar de?
Yeah. Reply from the participant side, please. Yes, anyone, please.
My lecture was after lunchtime. So everyone is lazy now. And it's 2:30.
Yes, 2:30 at this time.
And we are doing on Saturday. Saturday is for fun day.
There is a issue. Today is the FDP last day,
Yeah.
and it is Saturday also. So everyone is in the rest mode.
But I literally say this topic is very interesting. If anyone just dig in image generation, so start with diffusion model, and there are lot many research is going on still. You can do lot many things. The initial code is already available with us.
Yeah.
You can do lot many things with image generation.
In Keras Hub.
Yes.
Good, sir. You proceed, sir.
Okay. I have just run the code.
Mitrakshi Patil ma'am said, sir,
Yeah,
what can be done in text to image generation as a project?
There
Yeah.
are two kind of thing. Like one is if you are going for text to image generation, that means you can improve the version, because till now prompt engineering is there, but image is not as it is what we want as the prompt. So we can improve those accuracy from the background side. For example, text to image, certain GAN is available, certain diffusion model is available, but still their accuracy have a scope to improve. That's why we can say, like, you can go for those projects, number one. And number two is, if you are going from the front end side, so text to image, like in this time, you can give the prompt and the image will generate it. But there are very few websites like where with the help of text, you can generate the videos in a very quick manner. So that will, do for those things also. Wait a minute. I think the code is running.
Okay.
Wait a minute.
Thank you, Mitrakshi ma'am. Wait for a minute, Patil ma'am. I just ask a question to sir. Wait for a moment. Yeah, Dr. Umesh,
Yes,
there are
ma'am.
two questions from the participant side.
Yes.
One is Patil ma'am that said, can it be done as a research project?
Research project can be done if you are doing improvise the model.
And Dr. Shen Vajrang said, how to do animated video generation?
Video generation. There are number of models are also available for video generation also. When we are going to image synthesis, so similar kind of model is also working for video synthesis also.
Okay. Thank you. You proceed, sir.
It takes time. It's loading from actually the Kaggle.
And always Keras takes a lot of time
No, it will not take too much time. I think 2
for
minutes.
processing the data.
For 2 minutes. It will upload the data from Kaggle to here.
Kaggle to here.
Yet till it is loading. Anyone have a question, you can ask. Any participant?
No question from the participant till now. If there is a question, then I will ask. Yes, participants, if you are in question, please ask in the chat box or raise hand or unmute yourself. So we have to wait. It's processed now.
No, it is going because I think it takes time because I think this is going on. A WebEx is also going. So internet is consuming here over there also.
Yeah.
So that may be a problem.
No, not an issue, sir. We have to
Okay.
wait.
So either if it will complete, so we can show. Rest, if anyone want to ask any question, I have shared already. Can show some papers also if I can.
You have to just put these references in the chat box, sir.
Yeah, sure. So this is the UNet architecture for biomedical image segmentation. My screen is visible.
Yeah, screen is visible, sir.
So this paper is very interesting paper where we are using the UNet. So you can go through from this research paper and understand like how they have applied convolution layer and as well as the ReLU activation function and max pooling and like that. So downscaling and upscaling over there here. And then the similar kind of architecture you can design the research work. Like,
Please increase the size of the paper. It's not properly visible.
is it okay? Is it okay now?
Yeah, is it okay?
So like that, you can follow. It is a very important paper for regarding this thing. So they have applied for biomedical images, but later on you can apply to any of the field. Then one more paper is that is the model we have discussed in diffusion, that is DDPM model. So denoising diffusion probabilistic model. So you can use this model also. They have given their own GitHub repository. So you can use those code for regarding this paper. And here, like what kind of noise you can embed over there, it will be look like that. For example, we have a this when we are talking about the diffusion side, so you can see the pure noise image we have, and we get the generated image here.
So please share these papers in the chat box or the WhatsApp to me.
Sure, ma'am. Those who are looking for the research, they can go through this loss function here and change it according to your application as well as what task you want to do. They have applied on CIFAR 10 dataset. Okay. And that time the original diffusion is there and on 53. Then whatever model they have compared, you can check it out here. and it will work for you because there is a code, I think, if I will get. So here they have applied on church. Okay, and later on the images is changed, like in the generative images totally changed. They just took the style of the church and on the this scenery and mix it and generate one image. So it's a complete data set for that one. And the third one, so this is like we are going for designing space for diffusion model based on generative model here. So they have applied also on CIFAR 10 and they calculated the FID and SOTA. Okay, so these two parameters they have calculated here. The noisy image drawn from this and the ideal denoiser output is there. So when we talk about the denoiser, so denoiser will decide what output we will get here. Here the noise image is there. We introduce the noise and we get the noise will be removed over there. Again, they also give the GitHub repository, so you can access the code and can run on system. But it needs very high, you can say the high GPU or TPU based system. So my suggestion is that you can take online services from Google Colab, like Colab Pro, and that time you can run these programs.
Okay, sir.
So let me check. I think it have downloaded now. Okay, it's a previous one. We can run this for this one also. This is an older diffusion model where the it's still running. So it was run already because I haven't pressed on output side. So you can go through this stable diffusion model because there are number of variants have been done by the researcher on the diffusion model. So like Divyam Gupta, one researcher is there from the MIT. So they have done on diffusion something. So that time the model is stable diffusion, but the version is different. So like that, some NVIDIA persons also have done the similar kind of thing. So here you can see, this is a generated image. Here the horse don't have eyes, you can see, but astronaut is sitting over there, this horse. Like that, you can also use like in the air, or you can generate on moon. So like that, for example, you want to generate a sequence of images. So that time, like astronaut, we have passed like a photograph of astronaut riding a horse. So like that, you can generate a sequence of many images for that. You can see when you are going for non-square images. So that time you can get, again, this code is there also here. You can change the height width over there, and that time you can do. So this is the the flow chart for stable diffusion, whatever they have applied. So here you can see the latent seed is there. That is the Gaussian noise. Initially they have taken, they have used like 64 latent, and here we have just passed the user prompt. Then this clip method we have discussed, if you remember, text to image. It will combine to text encoder because it's a very variational autoencoder code here. We have embedded over there. Then text embedding will be here. Then text conditional latent unit architecture will be designed here. Then we get some conditional condition latent, then we get the variation autoencoder decoder, and it will be the output image like that. That's why it was generated, whatever we have seen. Yeah, so here you can see human with his low end, something it is generated like that. Am I audible?
Yes, you are audible, sir.
Yeah, and this is the the different image, like tiger in school uniform, like they change here like that, and the image is generated like that. So I think if you can go for the low resolution or high resolution, you can also apply these two method. Like efficient net, we know that is a pre-trained model, and we can apply with this diffuser model. So any other question? I think I have done from my side. If anyone want to connect me, so I will be
Yes,
available.
participants, anyone have any question? Because sir is binder. Kindly raise your hand or open a mic if you have any question. So I think there is no question from the participant side, sir,
Okay, so we
at this
can,
moment. Yeah.
okay, we can end this meeting. If we can open, like if you want to click the photo for all everyone.
Yeah, just a minute.
Yeah.
So participant, please open your video. Please open a video.
Yeah, wait a minute. Okay. I think it is not visible to me. Maybe.
Image is not visible to you, sir?
No. Actually, it was
My
hidden.
image is visible to you?
No. Actually, it is hidden here over there. No, I have hidden before presentation. Okay, that will be okay. I have
Just a
to.
minute. I just take a screenshot to you.
Yeah, I have to unshare this one. No?
Yeah. So
Okay, thank you, everyone.
thank you so much, sir, for a truly wonderful session and your insightful presentation and deep expertise for your topic. We deeply appreciate the effort and dedication that you put into sharing your knowledge with us. So thank you so much, sir.
Thank you,
And the
ma'am.
participants, thank you so much during the actively participation with the session. We will reconvene at 5 p.m. for the next session, followed by our validity session because today is the last day for this FDP. So the validity session at 6:30 p.m., which will include a quiz also. So you have to join at 5 p.m. today with a validity session that starts with 6:30 p.m. with a quiz. So I think I'm audible to all of you guys.
Yes, ma'am.
Okay, so we have to join again at 5 p.m. today. Thank you so much. Thank you, sir.
Okay, thank you, ma'am. Enjoy, and there are lot many scope. Still, I'm saying it is just starting of generative AI. If you have got some interest, like one line is scratched from my side or any of the speaker, so please start working. There are number of things still happen. Okay, the research is still going on. Thank
Yeah.
you.
Thank you. Okay. So I quit the session, participants. So we have to reconvene at 5 p.m. today again. Thank you.
Ma'am, I think you have to end because it is hanged
Yeah,
from my
yeah,
side.
definitely, sir. I will do.